We discussed auto collisions versus speed zones. This was done to see if there was any correlation between the two. In this presentation, each of us will discuss different topics related to our presentation. I will be discussing the introduction as well as the data from the research. Georgia will be talking about the background research as well as statistical analysis, and Eric will cover probabilistic modeling and the conclusion. To introduce our topic, the variables included are the speed limit, total amount of auto collisions, and the time. Our hypothesis states that an increase in speed limit can lead to a higher risk of auto collisions. Over time, as the production of motor vehicles have increased and the ability to reach top speeds has also increased, the amount of auto collisions can gradually become even more.
For our project, we had to look into speed limit history, kind of how it works, and just the logistics behind them. And so we were able to find that speed limits are set by each state. And in California, there is a 70 mile per hour maximum speed limit posted on rural freeways. And then there is a 65 mile per hour speed limit on the I-80 because it passes through urban and mountainous areas. And then the default limit is 55 miles per hour. And then if they want to change the speed limit, there has to be an engineering study conducted by Caltrans. We were also able to find more about the history of speed limits, where in 1974, President Nixon implemented a 55 miles per hour national speed limit. And then in 1995, the National Highway Designation Act was passed by Congress to remove the national laws regarding speed limits. Here on this slide, we have the number of highway fatalities in the United States versus a period of time starting from 1900 and ending at approximately 2015. This information was provided by fhwa.gov. Here we can truly see that there is evidence that the highway fatalities in the United States dropped after 1974 when Nixon made that decision. And then it continued in a downward trend after the national speed limit was implemented. And right around 1995, you can actually see this slight steady increase where the arrow is pointing. And that was when Congress made the decision to repeal the laws regarding speed limits. Here we also found a study conducted by the American Journal of Public Health, and they were researching the correlation between road fatalities and the raise of speed limits on different types of roads. They were actually able to find increases in fatalities in rural interstates and urban interstates when the states had raised their speed limits. They also ended up concluding that reduced speed limits and improved enforcement with speed camera networks could immediately reduce speeds and save lives, in addition to reducing gas consumption, cutting emissions of air pollutants, and saving valuable years of productivity and reducing the cost of motor vehicle crashes. Continuing on, we decided to focus on California, and after some more research, we were able to find a manual made by Caltrans about how they set speed limits, and they referenced the California speed limit law, where it said no person shall drive a vehicle upon a highway at a speed that is greater than is reasonable or prudent, having due regard for weather, visibility, the traffic on and the surface of and width of the highway, and in no event at a speed which endangers the safety of persons or property. And in order to change the California speed limit, an engineering and traffic survey must be requested and approved by Caltrans. There are also many different types of speed zones, which are regulatory, advisory, temporary traffic control, advisory and regulatory speeds, construction zones, school, truck, private facilities, special weather conditions, and variable. These all kind of attribute to what we really focused on in our data, which was urban car crashes and rural car crashes. And all of those different types of speed zones can really fall under those categories. In this data from the National Motorists Association, speed limits vary drastically from state to state. And from this graph, you can clearly tell that no speed limit in the U.S. goes under 55 miles an hour. Specifically, the aim of this project is to target California instead of the nation. So we're just taking a broad look at what the nation does as a whole here. Here, since we decided to focus on California specifically, this data was taken from the graph in the previous slide, and it shows just specifically California, where in rural areas, the miles per hour speed limit for cars is 70 miles an hour, and for trucks is 55. And then in urban areas, for a car, it's 65 miles per hour, and for a truck, it's 55. And then in other categories, like variable, in the types of zones we looked at before, the car, it's 70 miles an hour, and the truck is 55.
A study done by Eric Osiander and Peter Cummings in Washington shows the data collected over a span of 5 years. This study was done to show possible correlation between increasing speed limits and its effect on fatal crashes, as well as other crashes. From 1970 to 1975, the speed limit decreased, and there's a drastic decrease in speed from 1975 to 1945. The data chart above shows a gradual increase in speed from 1974 to 1999. This trend expressed above includes other factors such as the average in urban and rural areas. Rural 85% has the highest speed, starting with 65 miles per hour in 1975, and with a positive correlation leading up to 70 miles per hour in 1999. A negative correlation between crash rates in the year is shown in the above graph. Crash rates are decreasing from 250 to 50 from 1970 to 1999. The crash rates are seen higher in urban areas than in rural areas from the data collected in this graph. The correlation shown gives possible insight into what could be causing the decrease in crash over the years. As the years go by, the amount of crashes that have taken place decrease and then reach a more constant crash rate. Both graphs that have just been presented are by Eric Osiander and Peter Cummings.
For our project, we took into account the amount of car accidents in California over time in relation to what the speed limit is set to over time. In choosing our data, we considered the speed limits of every state in the United States for multiple zones, the total fatalities in the United States on the interstate, the speed limits per year in California, and the number of crashes in California on interstates. We decided on the data for the number of crashes in urban versus rural areas in California, the speed limit in California, and then the progression of years. Since the data that we plotted was on a downward trend, we can make the prediction that it will continue like that. This estimate also has evidence supporting it, such as the 1974 decision by Nixon to implement a national 55 mile per hour speed limit. With this supporting evidence, one can see in the graph and background research that there is some sort of dependency on the total number of car crashes versus speed limit.
For our probabilistic modeling, our group used figures from rural interstates and urban interstates in the state of Washington. Our graphs indicate a sloping in a negative direction, which means there's a steady decline up to the year of 2020. This indicates a crash rate decline for future years. Some possible causes of this could be improved safety designs, such as autonomous emergency braking systems in newer vehicles. Another cause might be improved traffic conditions, such as better traffic engineering. With all of the data we obtained during the course of our research, our group decided to do a supplementary analysis. We used California crash data from the NHTSA dating back 5 years. With this data, we created the histograms you see on the slide. These histograms reveal that most accidents occur on Sunday or Monday, which can be peak traffic days. Sunday and Monday produced the highest collision rates consistently for the past 5 years. With this information, we can infer that in the future, heavy traffic days will continue to produce the highest rates of collisions. From our own experience, we concluded that this can be due to the fact that multiple travelers either leave or enter town on weekends or beginnings. In the end, we concluded our hypothesis to be correct. From the data samples we retrieved, the information that we researched, and our analysis, we were able to come to that conclusion. While crash rates may be decreasing due to improved technology and better engineering, higher speed limits and improved abilities to reach top speeds result in an increase in the rate of fatalities in recent years when those collisions do occur.